So good morning to all. Thank you for being here so early in the morning. It's not too early. So I'll take the duty to begin this day. And I hope to give you a few elements on the Jaitapur project and the latest update regarding this project between France and India. So first of all, let me introduce briefly EDF as a group for reminding you some key metrics about who we are and what we do globally. So EDF is active across the whole value chain of electricity. I've reproduced here some key figures of our company in 2023. So as you can see, we serve customers, almost 41 million customers, and by customers it's residential, company, heavy industry, public entities, so mostly in Europe, but as well in other parts of the world. We have a capacity installed of more than 110 gigawatts, and this capacity has enabled us to produce last year more than 67 terawatt hours, or billion units. I know that in India you talk in terms of billion units. What you can see here is that when we say that we are an actor committed to low carbon growth and low carbon generation, you can see it from our footprint. So the electricity we have produced last year at more than 90% is coming from low carbon sources, and this has been made possible mainly due to thanks to nuclear, because as you see, nuclear represents more than the 3/4 of our generation. Regarding nuclear energy, so this is our main footprint in nuclear. So we are owning directly fully 66 reactors between France and UK, so it's more than almost 70 gigawatt installed. And we have as well some minority stakes in 2 Chinese reactors that we have built on the site of Taishan. Going more into details into nuclear, so we are not only an operator, actually, we are fully integrated across the value chain of nuclear industry, from the design, from the engineering and design, to construction and commissioning, to operation. And of course, because we ensure an end-to-end follow-up on our product, we are as well into the decommissioning and the retreatment as well. The nuclear industry is a very strategic industry in France. It's the 3rd industrial sector in France. It involves more than 200,000 jobs in France and probably thousands of SMEs. But within EDF itself, we have already almost more than 50,000 persons working on the nuclear itself. And what I've illustrated here is the capability integrated in EDF group itself. So we are in engineering with those 2 entities called Advance and KHNP, but we are as well into manufacturing through 2 subsidiaries. We have one being Framatome, being able to deliver the full equipment of the primary loop, INC, and provide a lot of services on reactors. The other one was recently acquired from 𝐓𝐈𝐌𝐄𝐒, and we call it Arabelle, which is, I think you have seen the stand today. They are present at the exhibition because they are manufactured actually in India itself, with wonderful sites in Sehan. Beyond our capability, our journey in nuclear is important as well, because learning from our journey enables us to project ourselves in the future, and we have learned a lot from our journey in nuclear. So here in a nutshell is the journey of EDF in nuclear. What you can see is that in the beginning of the 70s, EDF put into practice policy decided by the French government after the oil shock by launching the construction of several reactors, and this is what we did. So the fleet mode realization is a reality. It's something that we have achieved in the 70s, between the 70s and the 90s, where we have built almost 60 reactors within a period of 20 years. So after this period, during which we have built internally in France mainly, but we have as well assisted and helped building reactors to some partners countries like South Africa, China, Korea. After this period, we have entered into a phase where I would say the needs in Europe were a little bit lower. Europe had achieved a certain autonomy in terms of power generation, so the number of projects decreased, and in the same time the technology improved. We have jumped to the generation 3 reactor compared to the previous one. Of course, generation 3 means more complex reactor, safer, with more safety system, more features. So the combination of fewer projects and a more advanced generation has led to a slowdown in the pace of construction. But still, we have launched some projects like Flamanville, Hinkley Point C, Taishan, 𝐓𝐈𝐌𝐄𝐒𝐓𝐀𝐌𝐿𝐿, etc. Now we are learning from this period during which we have produced few projects. So of course we have had a lot of lessons from this period. We have understood a lot of things due to the regarding the supply chain capabilities, the need for having a fleet mode, the need to have and to provide to the supply chain visibility, so to enable the supply chain to get ready and to deliver the most efficient product as possible. And this is now why we are ready to launch a new wave of nuclear fleet in Europe, but in the world as well. The French government has decided to launch at least 6 EPR reactors in France, only in France, and they are studying the opportunity to launch 8 more. So this is a decision that we are expecting by next year. But France is not the only country in Europe which is leading the nuclear dance. The UK, after the Hinkley Point C project that is today under construction with EDF, are more than exploring the possibility of launching the Sizewell C project, which will be a replica of the Hinkley Point C. And the UK government is very serious about it because last summer they have committed £3 billion into this project as pure equity. So this is to illustrate how serious they are taking that. But other European countries and global countries, and India is part of them, and this is the reason we are here, are launching as well and are now convinced that the nuclear energy will provide is the key solution to tackle altogether development and climate change. This is just an illustration before jumping to the Jaitapur project on our ongoing projects. So I've mentioned EPR. Sorry if some of you were not aware, I should have put a slide of EPR. So EPR stands for Evolutionary Pressurized Reactors. So this is our model. This is the most powerful reactor in the world. We are talking about 1,650 megawatt, generation 3 plus, with a lot of safety features proper to the generation 3 reactor. And this reactor is not just a concept. Actually, it's operating in China. 2 units are operating on the Taishan site since 2018 and 2019. On the Taishan site, they broke all the record of generation for a single unit, because you can guess 1,700 megawatt running base load at 90% plus availability during the full year, how much electricity it provides. It works as well in Finland, 𝐓𝐈𝐌𝐄𝐒𝐓𝐀, since 2023. So there is 3 reactor EPR working today in commercial operation in the world, and we are expecting one more beginning of next year on the site of Flamanville 3 in France. We have reached criticality in September, and now the power is increasing slowly, and we hope to be able to connect it to the grid by end of this year or beginning of next year at the earliest. So it would be 4 reactors operating in the world. In addition to that, we are building it in Hinkley Point C, as you see, where we have already put the dome. We are receiving the heavy equipment, and so the project is on track. And this is the reason why the UK government has already decided with EDF Energy in UK to launch the preparations of the site and the floating of the first contract for the CIDCO project. Now coming to the Jaitapur project, the status update on this project. So what is this project? So maybe the global framework, and this is something that we need to remind. Obviously, as I mentioned in the introduction, nuclear energy appears now to more and more countries as a key solution to tackle global warming issue, and in the same time not compromise the development of a country. And on that objective, we can really say that both our country, France and India, are committed together to undertake this journey. So the nuclear civil collaboration is one of the key aspects, key pillar of the strategic partnership between France and India. And Jaitapur, the Jaitapur project is definitely within this nuclear civil collaboration, one of the key elements of this partnership. In a nutshell, what is the Jaitapur project? So we are talking about a project for building 6 EPR units on a single site, on the site of Jaitapur. The site of Jaitapur, if you don't locate it in India, it's on the west coast of India, in Maharashtra. So south of Mumbai, north of Goa, somewhere there. And 6 units on a single site, which will provide huge amount of electricity. We are talking about 10 gigawatt, you do the math. 10 gigawatt installed on the same site, providing almost 75 terawatt hour per year. So just an order of magnitude, if you consider the current consumption in terms of generation of the Maharashtra state, it represents 50% of the Maharashtra state current consumption. A very big project able to power millions and millions of Indians with low CO2 electricity. The journey on the Jaitapur project, and most of you have already heard about this project here. To recapitulate a little bit about what happened and what is going to happen next. So far, EDF took over from Areva this Jaitapur project discussion in 2016-2017. So this is the date at which EDF has started selling reactors abroad. Since we took over, were concluded between both governments, first step in 2018, an industrial way forward agreement that has set the framework of the discussion between EDF and NPCL. The main outcome being that EDF will provide all the engineering and procurement for the project, and PCL taking into their direction the construction and commissioning. And the project is for 6 units. Following that, we have submitted the first offer, which was not binding, end of 2018, and in 2021, April 2021, we have submitted a binding offer for 6 units to our client NPCL. So this binding offer was binding on our side. Unfortunately, it was not converged yet totally on a certain technical and commercial aspects. So this is exactly what we have done in the years of 2022 and 2023. we have discussed extensively with NPCL and the Department of Atomic Energy to be able to close as many technical points and commercial points as possible with them. Where now we are lying is to a residual certain number of points, technical points that needs to be tackled, that most of them relates to the licensability of the product. So to make sure that at the end, this EPR design, which has been already licensed in 4 countries, if you have followed what I've said, in UK, Finland, France and China, can be licensed as well under the Indian codes, requirements and standards. To perform that and to tackle some other issue, both our leadership in January this year, actually, during the visit of President Macron to India in January, has decided to call for a special task force that will be directly put under the leadership of both governments to tackle those remaining issues. I will detail a little bit later this task force. The idea is this task force, the work that will be performed with this task force will enable us to converge technically and commercially on a certain number of aspects, but to work out as well the competitivity of the project, and last but not least, to be able to finalize the financing, which is today one of the key elements that is slowing down the start of the project. And by doing all that, we hope to be able to submit a new binding offer. This time, the next offer we will submit to NPCL will be completely converged with our client, and so paving the way for the starting of the launch of the execution. To detail just on this special task force, because this is definitely the latest news on that. So the special task force that will be put in place between France and India will be directly co-chaired by both governments. When I say both governments, it's through their foreign affairs entity. So it just illustrates how strategic this project is for both countries. And obviously, NPCL and EDF will participate to the work of this task force. Will participate at the work of this task force, but the task force will encompass the technical and commercial aspect. It will as well tackle the financing one. So we can summarize by saying that the task force is going to address 3 main topics regarding the Jaitapur project. The first one is the licensing. This is what I just mentioned earlier. So to see how we can conclude on those the residual elements regarding the licensing and ensuring that the plants will be licensable in India. The second one will be to work out on the competitivity of the project, and we know that one of the key aspects to improve the competitivity of the project within the Indian environment is to work on the Make in India. So EDF is already committed to the Make in India. In the 2021 offer, we have already submitted an offer with a level of localized content around 20 to 25%. So if you include the construction that is under NPCL responsibility, we are reaching 40 to 45% of local content, which is already a fair amount, but definitely not enough. So this is something that we need absolutely to work on it. But to work on that, we have to define the proper condition to be able to work on that, and this needs some discussion at high level as well. Last but not least, as I mentioned, working on the financing of the project is as well a key element to be able to provide a sustainable project to our partner NPCL and the Indian government. This slide is just illustrating the Make in India, our Make in India journey and how we see things. So of course, obviously, the Make in India is start from the beginning, from Unit 1 of the program, and it will continue until the end of the program. Actually, the program, having 6 units on the same site, offer a unique opportunity to deploy an increase in local content progressively. At which pace this has to be decided by the supply chain itself, their ability to cope and to upscale, to upgrade, to reach the EPR standards. It depends as well on the pace decided by the client. So it is multi-factors. But what we can schematically illustrate here is that first we will focus on all and leverage as much as possible all existing Indian capabilities, which are multiple. The Indian supply chain is already serving one of the largest, if not the largest, fleet program in the world with the fleet mode, so a lot of capabilities there. So we are going to leverage as much as possible the existing capability and capacity. Then we have to see where we can, with a moderate effort in terms of training, qualification, because the EPR was designed according to different codes from the ones that are used in India, to see how we can bring as well additional supply chain, additional equipment to be manufactured to India. And last, and this is a very important point, to see how we can put and localize in India probably more critical component. This will call for significant investment in terms of course, upscaling some manufacturing plants, but in trainings and accompaniment, of course, from our French suppliers with the Indian supplier to make India capable as well to reach this level. Theoretically, we can see, I mean, no limit to this local content. It will all have to be decided during the special task force, depending on the willingness, the appetite, and the pace at which we want to implement that. Achieving that will enable us to, actually will enable India to get the most powerful reactor in the world, which make a very efficient use of land. And we know how much land is an issue in a country like India. So here on single site, you can deliver and you have a tool for a massive decarbonization and massive production of low CO2 electricity. With our Make in India journey, we hope to be able to deliver to India a product on which they are able to gain manufacturing autonomy and a certain technological sovereignty that can be leveraged much more into additional, why not, large reactor fleet, and yeah, and of course joining the community of the Gen 3 reactor, which demonstrate today is the highest standard that exists in the world. I think this is my conclusion slide. So if we have to retain something from this, so the discussion is still ongoing. It's progressing. Nuclear takes its pace, as usual. But the way forward is clear. This special task force today is very strategic for both countries to tackle the main issue and the main remaining point of the project. But this work is needed and useful. And if we achieve through that competitivity, the Make in India and the financing, we would be able to deliver actually beyond the Jaitapur project much more to India, because this project is the opportunity to transfer in a certain way a very powerful technology on which India, I'm confident, can materialize autonomy and sovereignty and competitivity for tackling its dual goal of development and decarbonization. On that work, thank you.
Good morning, everybody. I'm audible. So the topic is Speedy, modular construction, nuclear power plants, and role of private companies for Bharat Small Reactor. Actually, the speed of construction is important, but at the same time, accuracy is also important. So if we add speed and accuracy together, it can be achieved by we have to construct nuclear power plant in a speedy manner, but we have to also maintain accuracy. So if we add accuracy to the speed, then that can be achieved only when we go for modular construction or more automation, and of course quality assurance program has to be very, very stringent. So all those things comes into picture. But in case of modular construction, most of the manufacturing is done in the factory, where all those quality assurance part, then qualification part, and so many things are taken care, so that accuracy part is well addressed. So let us see in my next slide. I will give you some of the example how we are constructing nuclear power plant. So we started way back in 1970 to commercialize our RAPS 1 and 2, that was with the Canadian collaboration. After then we were on our own and we commissioned MAPS, then Narora Atomic Power Project 1 and 2, where we went for standardization of 220 megawatt, and then we went for Kakrapar project, that is 1 and 2 in 1980, and at that time we were, you can say that, very much sure that we will be able to construct nuclear power plant using modern technique and in a timely manner. But the time taken in Kakrapar Atomic Power Station 1 and 2 was around 8 years. And then government gave us the target, and we also in NPCI had our target that next project should be commissioned in less than 5 years time. That was the target, and that we achieved in RAP 3 and 4, KHEFT 1 and 2, and KHEFT 3 and 4, and at the top you can see this how to indicate this? At the top 540 megawatt you can see. So that we constructed in less than 5 years time. So 3 projects, Tarapur 3-4, then KHEFT 3 and 4, and RAP 5 and 6. These 3 projects we constructed in less than 5 years time using our learning process which we mastered in past. And further to that, we upgraded our plant to 700 megawatt in KHEFT 3 and 4. Here we have taken time because post-Fukushima design changes, design improvements were there. But whatever learning was there in KHEFT Tarapur 3 and 4, that was best utilized in KHEFT 3 and 4. So if we remove the idling time because of improvement in design, then Kakrapar 3-4 also was constructed in less than 5 years time, that we have seen. But in all these processes, industry participation, EPC contractor participation was, you can say that, very much consolidated. So equipment were manufactured by industry, Indian industries, and that were of very good quality. They were manufactured in time, and maturity was to this level that some of the units, or many of the units, we are operating continuously for more than 2 years. KHEFT 1 and 2 has set world record. One of the unit of this has continuously run for 962 days. That shows that Indian industry do have manufactured equipment and supplied to this level. That is of best quality in the world, and it has operated continuously for a very long time. And now our every unit is operating for continuously for more than 2 years, and we are manually shutting it down because of regulatory requirement. So hats off to the industry of India who have manufactured equipment to nuclear quality, and that is giving fantastic result. And that is why we are now targeting that if a small reactor, that is 220 megawatt, which is a proven design, if it is given to private sector, they will benefit out of that. And we have seen that atomic energy gives a leverage. that these private companies can invest money, they can construct with the power plant. Of course, only for operation they have to lease the plant to NPCL or Bhavani or now Aswani, 3 companies are there who are authorized to operate the plant. And during operation also there can be agreement in which participation of private company and NPCL can be together. That can be optimized. But today it is a fact that they can participate in a big way. And I will be just explaining in my further slides how Speedy we can construct, and then I will dwell upon those issues. So we can construct both a small and large reactor in less than 5 years time. PSWR will be 700 megawatt large reactors, and a small reactor can be 220 megawatt. So both we are able to construct in less than 5 years time. Of course, 220 megawatt can be constructed in even less than 4 years time. So that is possible with the private participation. Let us see how it can be evolved. And saving in time is also related to saving in cost, because nobody is able to construct power plant with their own money. They borrow money from the market, they have to pay the interest on the borrowing. And so if we are making the plant, constructing the plant in less time, that borrowed money will be earning interest for lesser time and you will be saving lot of cost. Also, if it is your money also, that money is also has price. If you park that money in the bank, you will earn interest. So if you are converting that money into profitable product, that is also a great achievement. So both way, constructing nuclear power plant in a speedy manner in less time is very important. Innovative construction technique has to be used. Actually, in SMR I am handling many presentations, but nobody is talking about foundation. In the foundation there will be civil job. So, and supporting structure will be also having either structural steel or many concrete job. So you should have innovative construction technique. It can be precast modern slabs or pouring of concrete using this pump concreting method, pressure boom, all those things. So these techniques are available in India nowadays, and we can construct civil structure very fast. And also we can have many structural steel components pre-assembled, and we can bring to site and do it in a speedy manner. And development of equipment and tools in synchronous with modular construction. Actually, this modular construction you can have, but there are many tooling required. In case of particularly PSWR, in case of pressurized water reactor, in case of I have seen reactor pressure vessel, that much tooling requirement may not be there. In case of pressurized water reactor or pressurized heavy water reactor, we have got tooling requirement for coolant gel installation, reactivity devices. So that tool development will be very important, even though you will go for modular construction. But that part has to be mastered. So NPC has mastered that tooling part, and they will be sharing those technology with the private company. And because of that process, the work which was being done earlier in more than 1 year time. So now we are able to complete all those things in less than 5 months time. So there is substantial reduction of time for equipment, the reactor equipment installation. And 3D modeling already we have gone for. And earlier in past I explained you in 1970 itself we started. We faced a lot of field interference issues. So now those things have been removed, because we are now entire plant is available on 3D model, and while we are modeling, we are able to remove all interface issues, and in the field we do not face any problem, and there is no need of rerouting the pipe or rerouting the cable tray or rerouting the ventilation duct. So all those issues have been resolved. So this is the advantage. And of course, 3D modeling can be used very well for training programs. Then effective project management is very important because so many large number of equipments, piping, fittings, electrical components, CNI components are involved. The timely delivery to site, its timely manufacturing, and all those things have to be coordinated. Effective contract management, so that can be done by effective project management. So all these four components are very important for speedy and project execution, which of course private sector is also having this in their mind. They have also practiced in their thermal power plant construction, hydro plant, solar plant, wind energy. They are using all these techniques. So they are the right person to enter into nuclear field, starting with 220 megawatt ESR, and they can do a fantastic job along with NPCI. You can see the slip forming method, stack. It can be modular, but by slip forming method also, you can construct entire stack in less than 2 months time. So the question comes, why to go for modular? Now we have to also economize. Suppose you go for modular and you spend more money. That is not also a good thing. So we have to optimize. Where we have to go for modular, where you can use this slip forming technique and save time to construct and also save cost. Then we have also seen that we have to focus on horizontal and vertical construction. Many times what happens that we construct reactor building vertically and forget about other buildings, control building, reactor building, so many adjacent buildings are there. So we have now focused that there should be uniform process in all the buildings, so that when you reach to the top in one building, you should be able to touching the top in all the buildings. So that simultaneous construction, erection activity and commissioning activity should start in all the buildings. So these are the learning from the past. Generally what happens that suppose in one building, whatever equipment or systems are there, design is present there. You concentrate on that, and where design is not present, you need that. So that sometimes, that many times lead to delays on the overall project schedule. So if design is present, it is of great help. You can concentrate on all the building and complete everything together. So this is the advantage of Bharat Small Reactor, where design is present and you can concentrate on all systems, all buildings at a time, and you can move very fast. Now you can see example of this PRL, that is ring line, pre-assembled ring line, that we have done at Katra Park, where containment is line. So in 220 megawatt also DSR, containment is line, and this technique can be used for speedy construction of reactor building. So here you can say that it is a part modular construction job, but with this lot of saving in cost is there. So with this technique, with partial you can say that modular construction, we can save time and cost. And this technique will be available for 220 megawatt RF. Same example that has been repeated in IC-Wall in Jaitapur. How you can see that this ring liner can be put, and where is the indicator? Hello? Indicator? Press this. So we can go on putting this and concreting and going fast to the top. So I have done the calculation, and you can also do when you are doing a small reactor. Entire containment can be constructed in 1.5 years. So that much saving is possible. So in 2 years you can construct entire civil job, and in balance 2 years you can complete. Actually, you can start equipment installation well ahead of 2 years time, and by the end of 4 years you can commission the rig. This we have demonstrated in Talabur Tier 4 itself. that I remember in June 2002, we were completing the civil job, and in next 2.5 years we commissioned the plant. Here are the explanation how much time can be saved. So this is again example of dome construction. Here we were taking lot of time for installation of dome. Actually we were doing the structural erection here, and then we were putting the dome, and after construction of the dome we were cutting the structures, removing that, and all this process was taking a lot of time. So we had the concept now of prefabricated this dome, which can be just prefabricated on the ground, lifted by crane and put it on the top. And as soon as we put, next day we can start work below this. So this has saved almost 1 year time. So there is a lot of saving of time. So by partial modular construction, we have demonstrated that we can save a lot of time. And that has to be demonstrated in Bharat Small Reactor by, of course, and along with the NPCIL, we have to achieve this target. Now this is again example of top hatch beam. So at the reactor building top, these are the top hatch beams which has to be installed. They are of high precision. Manufacturing is required, and this can be lifted by crane and put in the position. And if you do in situ job, it takes a lot of time. Accuracy is also not there. So this is factory made, brought there, and we have installed it. And this also saved almost 4 to 5 months time. So individually we have seen that at Tarapur 3 and 4 and at Katrapar, we have demonstrated how we can save time. And that idling time we have to remove by better project management. And we can see that even our 700 megawatt can be constructed in less than 5 years. So at present the BSR is limited to 220 megawatt, but floor is open. If some company wants to go for 700 megawatt, that can be also constructed in less time. And of course this technique can be utilized for our foreign reactors also. Because India is constructing in Kudamkula power plant with Russian collaboration. So all these techniques are being used there, and we are able to construct that plant also fast. And now whenever Jaitapur project will come, that land is already acquired and that is in position. These techniques can be utilized there also. Even Westinghouse technology will come. All these techniques can be utilized. So Indian industry, actually basically in India, mainly Indian industry or EPC contractor of India is going to work, whether it is BSR or any foreign reactor or SMR. And our Indian industry and NPCI and BRC are fully capable of launching any technology in India, and that can be done very fast. Here are the examples how saving of time. Similarly, you can see here how this D2O tower, this very long tower height, and by modular construction that can be done very fast. Again, polar crane brackets in Kudam projects. In 1 and 2, this process took very long time, almost 2 years. But in 3 and 4, only in 2 months it was done. So there is the advantage of modular construction. Similarly, this gas insulated switchyard at Tarapur 3 and 4, within 5 months, entire thing was assembled and commissioned. So that is the advantage. So this can be utilized in any of the reactors, this technology. These are Calendria vessel that is manufactured by our Indian industry, and it can be brought to the location at site, and by lifting by crane it can be installed. So this process is fully established for 220 megawatt BSR as well as for 700 megawatt. Similarly, you can see this end seal. This is also manufactured by Indian industry. It is brought to site. It is weighing around 230 ton with the ball inside, and it can be simply in few hours time it can be installed. And earlier actually we were taking more time to weld this end seal with Carandia. That time also has been reduced from 5 months to 1 month. So a lot of saving in time we have demonstrated in our past year. This you will see, this is one side is Carandia and one side is end seal. After lowering of the end seal, we lower the Carandia and weld it. So entire process can be done very fast. We are the welded part. Now steam reactor also. The steam reactor is manufactured in India by Indian industry and brought to the site, and by crawler crane of different capacity. You can say that 9,000 ton meter or 12,000 ton meter. Steam reactor weighing 200 ton. They can be installed in only few hours time. Very advantage. Now this is the technology for coolant channel installation. Here NPCIL has mastered this technology and all tooling have been developed. There is a zero rejection. Earlier we used to have rejection in installation. Now there is zero rejection. And we are able to install Carandia tube in less than around 1 month time, total Carandia tube. And coolant tube in around 2 months or 2.5 months time. Against 1 year time, this we are taking earlier. So lot of saving, lot of learning advantage is there, and that is available for Bharat Small Reactor as well as Enerbility. They are how pre-assembly job is done. So here also we have mastered the technology. Without any error, we can proceed and we can do very fast job. And all this technology is available for Bharat Small Reactor. We will be sharing with our partners who are participating in this, and certainly these things can be done very fast, and of course with great accuracy. Same thing is, it is very involved job. One can think that why private sector cannot do on their own. So in the beginning it is not possible. They have to work with NPCI, because NPCI had a learning curve, and they have to work together and learn this, and then only it can be done fast. So in the beginning for 5 to 6 years, they have to work with NPCI or NPCI retired who have worked, and they should learn the technology, and then it can be repeated on their own. And at that time perhaps Act will also change after 4 or 5 years. So they, on their own they can multiply. Only I will tell you from this program that fuel will be concerned, because everywhere nuclear power plant is being installed in a large US, Europe, UK, China, everywhere. So there will be pressure on uranium supply. So we have to focus on other fuel, that is utilization of coal. So a lot of technology is available. One of the technology they are talking about annealed fuel also. So there is merit in that. So in parallel there has to be debate and research on those fuel also. If fuel security is there, then ESR can play a good role, not only for India, but for any other country. And even SMR technology and learning of ESR can be, you can say that merged, and speedy construction with a saving of cost should be possible. The other, just the example how end fittings are installed. Just example that this dome construction was earlier done by Larsen & Toubro. Now same technology was mastered by Doosan construction company also. So a technology which is developed by NPCIL is given to various people. It is given to Larsen & Toubro, it is given to SCC, now tomorrow will also be given this technology. So they can do a precision job with NPCIL support. Now this is precision job for feeder installation. Actually, unique type of feeder design is there in our PSWR that requires lots of precision, fabrication and erection. And that has been mastered, and it can be done in very less time with great accuracy. tuning machine also. This is also manufactured by Indian industry. Now the benefit is that entire component from, you can say, the scratch to final, it can be manufactured in India and supplied and installed. This is the advantage of Bharat Small Reactor and SMR-Related. And these learnings will be certainly useful for bringing in foreign reactors and constructing in time. If they are giving guarantee of fuel security and if they are working to be economic. This is the layout of 3D model. Now we are also changing the concept of packaging. You can see that earlier so many packages were there. Now we are concentrating on 3 packages: nuclear island package, turbine island package, and our balance of plant package. So accordingly, organization also we have changed. So with this concept, NPCIL nowadays is going to launch many projects. For example, earlier we were constructing only one project at a time. Now with this concept, we are able to construct 4 or 5 projects at a time. This is the advantage. And by leveraging this BSR initiative, certainly we will have in parallel 10, 12 more projects in hand. So by different method of project implementation strategy, we can have many projects in India, and of course, if law permits in abroad, many small reactors also. This is just an example of overall project schedule. This was completed in 4 years, 11 months, 26 days time, that is Jaitapur reactor. We have the actual timing. Only thing is that when we construct nuclear power plant, there is overriding priority of nuclear codes, industrial safety and radiation safety. Industrial safety is common to you outside nuclear world also, but industrial safety in the case of NPCIL, nuclear power plant, is seen by Atomic Energy Regulatory Board. So it is more stringent. That's why it is mentioned here. So there is schedule is having second priority. First priority is to nuclear codes, industrial safety and radiation safety. So this is the change. That's why in DSR, private sector has to align with NPCIL to learn this overriding priorities and learn this review process. Anything you do, it will be reviewed by 3-tier committee. Most of the thing, that is the PDSC committee is there, Project Design Safety Committee, Apex Safety Committee is there, they will review, then finally regulator will do. So 1 month time generally for review process is required. So one thing can be done in case of DSR, since design is frozen, you can be given go ahead for the construction in the beginning itself, and up to fuel loading, we may not ask any question. You can straight away go ask fuel loading, then there can be review. So those things can be optimized. And there are many innovative ways to come from you, and it will further add to our manufacturing process and construction technology. Many digital support will be there, AI intervention will be there. So many improvements are possible. And since NPCIL is joining hand with now private industries for under BSR initiative, which is permitted by Act, there is a possibility of many good things to come. And let us see how those things are coming. As far as BSR is concerned, I will just explain you. There was a confusion that Atomic Energy Act provides private participation in a joint venture. So that we have seen in totality, it is not possible. Only 2 government companies can join hand in private as a joint venture, and they can construct the power plant. That's why NPCIL has signed JV with NTPC, and new company Speedy has been formed. They are now authorized to do nuclear business, so they will be doing. And one 𝐓𝐈𝐌𝐄𝐒 company is already formed, which is authorized to do nuclear business. Of course, they are for utilization of plutonium, like fast breeder reactor. And NPCIL is in the business of utilizing this uranium, natural uranium or enriched uranium, uranium-based nuclear power plant, NPCIL, Ashwani will be, Ashwani of course, Ashwani can do both. Utilization of this natural uranium as well as plutonium. NPCIL can also do, but as per NPCIL has got mandate to work on using natural uranium and this uranium-based nuclear power plant. Now comes how private sector can participate. So they can participate under PSR initiative. Means they can provide land, they can provide finance, they can award contract, they can execute contract, but at the same time that will be under umbrella of NPCIL. NPCIL will be the project proponent for taking environmental clearance, for taking ARV clearance. So that act wants. So administrative ownership has to be with NPCIL so that they can apply for licensing process, ARV clearance, MOA clearance, all those things. And fuel is under control of Department of Atomic Energy. So NPCIL has to source fuel for BSR, or this private investor has to source fuel through NPCIL, through DAE, and heavy water also from DAE. The two things, heavy water and fuel, has to come from Department of Atomic Energy. Of course, one Jet component is there. That is also being manufactured by our nuclear fuel complex. That has to come from there. Of course, there is no restriction on that. It can be imported also. But fuel and heavy water has to come from DAE. So there will be, you can say that an agreement which will support private investor who have nuclear power in India. They will full support fuel supply guarantee and heavy water guarantee. There will not be any issue. But in the beginning, certainly, in a very cautious manner, things will move. And once plant will be constructed and commissioned, and learning process will be established, at that time, perhaps Act will also change. And they will allow private sector to go in a big way. They can go for, in between, they can also think of a small modular reactor and other reactor. But things are evolving. Now slowly things are opening up and evolving. And within the Atomic Energy Act, we will see how we can proceed. Thank you very much.
Hello, this is Soonhong Jeong, in charge of this presentation from Doosan Enerbility in Korea. It's very nice to see you. Through this event, I'd like to share the Doosan's business plan. Let's begin the presentation. This material will cover from Doosan Enerbility's vision to Doosan Enerbility's SMR business. The content consists of overview of Doosan Enerbility, Doosan's nuclear power plant business, Doosan's SMR business strategy, Doosan's readiness for SMR project. The vision of Doosan Enerbility is to be a global leader in power and water. The company was established in 1962. Today, the company has grown into a well-recognized company in the global market with over 12,000 employees worldwide. Doosan Enerbility is an integrated energy solution provider. Doosan Enerbility covers the entire scope of power plant industry. In the first phase, engineering and material, Doosan can perform the plant and component design engineering, such as component design drawing and stress analysis. Additionally, Doosan can perform forging, casting, 3D printing. In the second phase, equipment manufacturing, Doosan can conduct detailed component manufacturing for boiler, gas turbine, nuclear major component, steam turbine, generator, and wind turbine. In the third phase, construction, EPC vision of Doosan Enerbility can construct all kinds of power plants, such as conventional power plants, nuclear power plants, wind farm, and more. In the last phase, Doosan can provide the entire scope of service, such as R&M, maintenance, repair, overhaul, and O&M. The company is comprised of the three business groups. First, nuclear business. Second, EPC business. And third, power service business. Nuclear business includes forging, casting, and nuclear major components. EPC business includes power plants, EPC, water desalination, and treatment. Power service in charge of turbine, generator, boiler manufacturing, as well as plant R&M, O&M. This is Doosan's manufacturing complex. It is located in the southern part of Korea, in a place called Changwon. This complex consists of main office, foundry, forging, boiler, turbine, generator, nuclear shop, and dock facility. Utilizing this manufacturing complex, Doosan has a lot of experience in carrying out 34 reactor vessels and 124 steam generators in Korea, USA, and China. This slide shows main products and service in nuclear business. Doosan is an absolute expert to manufacturing and design entry-press components such as reactor vessel internal, steam generator, reactor float pump, CDF, pressurizer. In the entry-press with the INC, Doosan can handle the entire sequence of all major components from design to manufacturing. Also, in the nuclear turbine generator, this scope will be performed by Power Service Business Group. Additionally, Doosan is involved in the BOP business, such as small vessel, tanks, and small other components. In the service business, Doosan has a lot of experience in component replacement, repair, and maintenance. Since 1980, Korea has built 27 domestic nuclear power plants. As the key player, Doosan has continually manufactured the main components for more than 40 years. In the process, we have gained extensive experience in the manufacturing field. Doosan has carried out not only domestic projects, but also overseas projects. So far, Doosan has supplied 34 reactor vessels and 124 steam generators, both domestic and overseas. In addition, Doosan has also a lot of experience in the replacement line. Through all the achievements we have made, the strengths of Doosan can be highlighted. First, with its own forging shop, Doosan has been supplying large forgings. This unique capability gives us competitive edge from raw material to final product. With this strength, Doosan will provide the most valuable solution to the nuclear power plant business. I'm going to explain the overseas circumstances and characteristics of SMR. Generally, SMR means a reactor that has electric capacity of up to 300 megawatts. Why SMR? Why are a lot of developers jumping into the SMR market? Why are a lot of countries making policy to deploy SMR. There might be various answers, but we can find out the reasonable answer based on our global situation. So I'd like to explain the current situation we are in. First, a climate crisis. All countries are trying to achieve decarbonization by 2050. Thus, many countries are looking for carbon-free energy. Second, technology. Almost the high-tech industry needs the substantial and stable energy resources such as AI and data centers. Third, high financial burden. Conventional nuclear power plants have a fixed electric capacity, which means customers always have a large financial burden, even if they only want a small amount of energy. Fourth, need to transition old coal power plants. There are so many old coal power plants in the world. Almost all the coal power plants need to change to carbon-free energy resource to address the climate crisis. I would like to explain the SMR's characteristic. The most important is enhancing safety. In case of SMR, all accidents will be cooled down and shut down naturally without any action. This is a very important point in terms of safety. Second is versatility and flexibility. SMR consists of several modules, which means SMR can adjust their electric capacity based on the demand at the site. Third is construction. If we get a lot of order for SMRs, the manufacturing schedule and cost will be reduced and optimized. The fourth is application. The SMRs for process heat resource can be more easily utilized in collaboration with other plants, such as the hydrogen generation or water desalination. This slide shows the SMR development status in the world. There are about 80 SMR developed worldwide. According to the SMR market status and situation, Doosan has a vision to be a SMR foundry in the near future. Most SMR developers are startups, families, and do not have a manufacturing experience. This is why Doosan has been cooperated with SMR developers in the early stage to verify the SMR final design through various manageability assessment or mock-ups. In this situation, Doosan utilized our strengths to be a global top-tier SMR founder. Casting and forging is a basic process to manufacture the nuclear material. In this case, the material is made large and then machined, followed by individual welding of nozzles and attachments. It takes a long time. By using PME technology, your metal powder is tightly packed into a thin cast and pressed at high temperature and pressure. The material can be made with minimal additional processing, reducing the manufacturing time. We plan to secure feasibility test and basic technology by 2028. To prevent corrosion, The inner surface needed to be clad with stainless steel or nickel alloy steel. Currently, this is done using a mechanical welding process, which results in an average welding thickness of 5 mm and requires a long time. In the future, by using laser cladding technology, we expect to increase the deposition rate per hour and reduce the cladding thickness, which could significantly shorten the manufacturing time by more than 50%. We plan to install the equipment in the 2025 and secure the welding technology by 2027. Currently, the process welding of cell is performed using mechanical welding process after machining the welding preparation. This process requires a lot of welding material and over 100 welding passes, resulting in a long working time. In the future, by using the electron beam welding, we expect to significantly shorten the manufacturing time by more than 90%, as it allows for rapid welding in single pass without welding material. We plan to install the equipment 2026 and secure the welding technology by 2027. Doosan is focusing on improving quality while reducing manufacturing time and budget through these innovative technologies. This is Doosan's readiness for SMR. Thank you.
Honor to speak and introduce Korea Hydro and Nuclear Power to all the guests seated here today. So I'm going to briefly touch on KHNP's ecosystem and key projects that we had completed and embarking at the moment. So I'll start with the business overview and conclude with ISMR. So Korea Hydro and Nuclear Power, we generate about 31.5% of the total domestic power generation within Korea. And out of 31.5%, about 30% is from nuclear power. So nuclear power accounts a large portion of energy generation in Korea. Now on the right side, the power generation, total power generation by KHNP has been constantly increasing. In 2023, it has amounted to 185 gigawatt of energy. So the installed capacity, as you can see, is 31,000 megawatts. So KHNP has been building continuously for over 50 years. We started our first construction of nuclear power in 1970, starting with Gori nuclear power plant number 1 and 2, and we have completed the new nuclear power plant, which is called Shinhan number 1 and 2 in 2024. So we have a proven track record of building continuous nuclear power plants within Korea. This is our general organizational chart detailing our 12,000 employees working for the nuclear industry. Second is the nuclear energy, which is our flagship business. So as I have said, we generate about 30% of electricity through nuclear power generation. On the left side, in 2023, we generated 170 terawatt hour of energy through nuclear power, and it costed about $6.9 billion. It's about 12.5% of the total expenditure of electricity, and compared to coal and LNG, it's a very cheap source of power. So based on the Korean environment, we spend about $0.04 per kilowatt of energy. This details our key milestone of our projects within Korea and abroad. We first exported our power plants in 2009 along with KEPCO, and we entered Egyptian market and also Europe by signing contract with Czech Republic in 2024. As a sole nuclear power generator within the country, we have total 26 units of nuclear power plants operating in the country, and 4 are still under construction. I will explain more on the next slide. But not only do we generate power through nuclear power, but we also have renewable sources such as hydropower, pumped storage hydropower, and also renewables such as wind cell and fuel cell and solar power as well. And the map on the right details the overall the overview of our power systems across the country. So I will now explain about key projects. So there are 26 nuclear power plants across the country. They are mostly concentrated along the eastern coastline, and there is one power plant located on the west, and total 26 power plants are operating to provide electricity domestically. There are 2 new power plants in the pipeline that we are building at the moment. It's called the Sharan Nuclear Power Plant Unit number 3 and 4. It has 2 units of 1400 megawatts of nuclear reactor. Reactor type is APR 1400. We expect to finish this construction until 2026. And on the right side, this is a pretty new construction that we embarked last year, April. It's the same type of nuclear reactor. 2 units are scheduled for construction. We expect it to complete until 2033. It takes about 10 years for us to build new power plants. So this is our first nuclear power plant project abroad. It was a power plant in United Arab Emirates. It started in 2009, December, and we provided 4 units of APR 1400, totaling 56,000 megawatts. We expect that this 4 units of APR 1400 will provide 25% of UAE's total power demand. And this was our most notable project because we were able to finish this project on time and on budget. And the contract price was $18.6 billion. We are going beyond our UAE project. We secured a project in Egypt along with Can-Do Energy of Canada and Ansaldo Nuclear in Italy. The scale is providing 4 units of 1400 megawatt of generator. The total contract price is $30 billion. So the duration is from 2022 to 2029. And we are building the secondary part of the Egypt nuclear power project. On the right side is Romania. This is expected to complete in 2026. We are building the tritium removal facility project in Romania, and we are still negotiating some details of our contract at the moment. In 2024, we were selected as a preferred bidder for the Czech Republic nuclear power plant project. The scope is providing 2 units of APR 1000. It has a potential to provide up to 4 units. It depends on the negotiation details, but we hope to secure the 4 units of the project as a whole. And estimated project cost is about $17.6 billion. So the timeline is, if everything goes according to the plan, we are signing the contract in March 2025, and then construction will start in 2029. This is our SMR project. As you can see, the background, this is our conceptualized image where it details that the SMR power plant can actually coexist with the city. The SMR that's being developed by KHNP is called ISMR, which stands for Innovative SMR. It's about 100 times smaller than the conventional large-size nuclear reactor. It has four reactors, small modular reactors, each generating about 170 megawatts of energy. So in total, 680 megawatts of power will be generated by the ISMR. The construction cost for this type of SMR is $3,600 US per kilowatt, and the life expectancy for this is expected to be 80 years. So there are three benefits, as you were briefed earlier: economic efficiency, safety, and flexibility. As for economic efficiency, why is it efficient? Because we will be building SMR in-house within the factory and then ship out to where the plant is required. Unlike the conventional large-size nuclear reactor, where you need to build from the bottom to top, the ISMR will be shipped out from the factory to the site where it needs. In terms of flexibility, large number of nations are adopting solar power as a means to achieve net zero target. South Korea has also fielded quite a large capacity of solar power as well. But when solar power generation goes up, there's an issue of a duck curve phenomenon where there's an imbalance between the demand and supply. So energy storage solution needs to be introduced to flexibly meet the demand and supply. But we believe that ISMR can play a vital role in controlling the demand and meeting the supply. So whenever the demand goes down, the ISMR will kick in, and whenever the demand goes up, ISMR will flexibly control the output. We also hope to utilize for district heating, desalination, and hydrogen production. So this details application area of the SMR. Of course, we'll provide electricity, and through the high temperature steam electrolysis, we will secure hydrogen, and the steam coming out from the SMR will be used for hot water heating, and then steam combined with seawater we will utilize SMR for desalination facility. So this is also a conceptualized proposal that we are throwing out to the market. So on the right side, as you can see, it's a smart net zero city, SMR-driven smart net zero city. From the top, there's an SMR power generation site, and all the products, electricity, hydrogen, goes down from the top to the bottom through smart farm, smart industry, and smart town. So the smart farm will use desalinated fresh water, and then smart industry will use hydrogen and heat that is generated through the power generator. And the smart town will be the ultimate beneficiary because the hydrogen bus and then the cheap electricity will be utilized within the town. So through the ISMR-driven smart city, we strive to achieve carbon neutrality, urban competitiveness, and acceleration of distributed energy resources. Based on our calculations, the combination of 80% of ISMR and 20% of renewables were the most effective combination for when striving to achieve the carbon neutrality and also in terms of cost effectiveness. So this is the last slide. I will briefly explain about the development status of our SMR. Last year, we completed the basic design project. It took about 3 years. ISMR is basically the KHNP's in-house project. It was also participated by Korea Atomic Energy Institute, along with other stakeholders. Our next target is to pass the feasibility study by the government. It started last year, will last about 6 years. And then we aim to acquire the standard design authorization in 2028 and then enter the market in early 2030s. So it's about combined effort between the industry and government and also external stakeholders before we actually propel SMR into the market. So on the bottom, it simplifies the version of what I have just said. Thank you very much. This concludes my briefing.
What are some of the key issues, concerns that we face, and then end the session with some mitigation measures and some changes that are required in the regime to really grow the nuclear power. So I thought I'll start off with this slide, which shows the current current nuclear capacity in our overall energy mix for the country. So the current installed capacity that we have for nuclear is about 1.8% of the total installed capacity. Now, while the nuclear power has grown about 70% in the last 10 years, its proportion in the overall energy mix has gone down from 2 to 1.8. Whereas renewables, we can see, has gone in the last 10 years from about 10 to 44%. Now, obviously there are reasons nuclear power lost focus, but now everybody seems to realize the role nuclear could play in the energy transition story of the country, and that's why perhaps the renewed focus on renewable energy. Now, starting off with the current regime that we have, the main act dealing with nuclear power in the country is the Atomic Energy Act. And this is the act I think we've kind of touched upon. This sets out the basic framework for the development, control, and use of atomic energy. And this currently provides that only the central government or a government company or a government company in collaboration with another government company are the entities which can either own or operate a nuclear power plant in the country. And this, and then there is a licensing requirement which comes from the rules which have been framed under the Atomic Energy Act. So only an entity which has been granted this license following the detailed process is entitled to own and operate a power plant. The Atomic Energy Act was amended in 2015, and this is pursuant to which joint ventures between two government companies were allowed, and pursuant to which we are seeing that recently 𝐓𝐈𝐌𝐿𝐿 has been formed between NPCIL and NTPC. So currently we have only 3 entities in the country which can own and operate nuclear power plants. So it's NPCIL, 𝐓𝐈𝐿𝐿, and the recent 𝐓𝐈𝐿𝐿. Now, the whole regime under the Atomic Energy Act sets out various rules which give you the detailed process, safety standards for developing and thereafter operating a nuclear power plant. And the regulatory authority has been constituted as the AERB, the Atomic Energy Regulatory Board. Now moving on, I think what we've been talking about, the private participation, I'll break it out into foreign investment and the private participation. Starting with the foreign investment in the country is governed by our Foreign Exchange Management Act and FDI policy, which currently does not allow a foreign entity to invest in the atomic energy sector or own nuclear power plants. And however, what is currently allowed, and which is also pursuant to a clarification that first Department of Atomic Energy, which is the main another regulatory body governing atomic energy and nuclear power plants in India, that said in 2016 for the first time that foreign companies can invest in the supply chain, which thereafter was further clarified by them in 2020 to say there is no restriction for foreign investors to come in and be part of the nuclear power industry as the suppliers to be forming part of the supply chain. But I think the important piece is there is no government notification that has been issued or a circular pursuant to the FDI policy which clarifies this aspect, and which is what is required, and perhaps at some stage this is something that would come through. Now, with the investment, talking about private investment, the main act, I thought the next important piece is the whole civil nuclear liability regime. That's also been touched upon over the last yesterday. This is the main act which India has enacted to talk about the civil nuclear liability. While we enacted the act in 2010, which came into effect in 2011, the action around the foreign suppliers in the nuclear power industry kind of commenced, I would say, in 2016. Perhaps as Stéphane also mentioned, that's when EDF acquired Areva. And the reason for that was that India, while it had signed the Convention on Supplementary Compensation for Nuclear Damage, CSS as it's kind of famously called, in 2010, it ratified it in 2016. Now, by ratification, you mean the Indian government confirmed that its local laws, which is the CLND Act, complies with the provisions of CSS, which is because it had kind of ratified the convention. Now, briefly, I'll touch upon what the CLND Act covers, and we'll talk about various aspects, and we'll talk about the various concerns that the suppliers have had with this act. Now, the CLND Act, as is an international standard, goes on to say that it is a no-fault liability regime where the operator of the nuclear power plant is responsible for the operations and all nuclear incidents and consequent nuclear damages that happen at the nuclear power plant. There are certain exceptions that are carved out, certain force majeure events, if a damage happens during transit, those are carved out. Then also the Act provides for the scheme and the manner of seeking compensation, the whole detailed process, the timelines within which the compensation must be informed, there is a claims commissioner process, but in effect it kind of goes on to give the detailed mechanism and say that the operator is liable at the first instance to pay for the damages arising from a nuclear incident. Now, because the liability hinges on a nuclear damage arising from a nuclear incident, the Act goes on to define these two, and obviously the definition is expansive, and it goes on to cover all damage that is caused, including your loss of life and property. And even nuclear incident is defined as either one incident or a series of incidents which leads to the damage. So, moving on, now the important aspect, now the quantum of liability, right, which kind of the Act provides. So, the first amount of liability that is prescribed in respect of nuclear damage is 300 million special drawing rights, which is as determined by IMF, that's the international standard, or whichever is a higher amount that gets notified by the central government. The Act goes on to say that the liability of the operator, which is primarily NPCIL, is capped at 1,500 crores INR, which is roughly equivalent to USD 178 billion currently. Now, this is the liability applying to all nuclear power plants having a capacity of 10 megawatt and more. In certain instances, and that's the cap and the important bit, because what we'll touch upon later is the right of recourse of the supplier, which is linked to this cap of the total overall capacity. Now, if the damage happens for a quantum more than this amount, then central government of the country is liable. And thereafter, because we've ratified the CSC, we can dip into the international funds for a greater amount of liability to be paid. And certain FM events are to be borne by the central government. Now, the other important aspect, as a security for the liability, the Act mandates that the operator must get some form of security or insurance for securing its liability that could arise. And pursuant to this requirement, which is set out under Section 8 of the Act, the India Nuclear Insurance Policy, INBP as it's famously called, was established in 2015, And the intent was that it must have the cap of 1,500 crore, which is the cap required under the Act. And this was formed by GIC, the main reinsurance running with the process, and a couple of reinsurance also joined the pool. Now, the whole idea was to provide for a risk transfer mechanism to cover the liability of the operator, and thereafter the liability of the supplier, which arises pursuant to an operator paying for such compensation. Now, this whole idea behind this insurance was that it would give the comfort obviously to the operator as well as the various suppliers, so that they know that their liability is covered by this insurance policy in case unfortunately an incident were to happen. And also there were FAQs issued which provide what could be the quantum of premium, which is linked to what the probability of a nuclear incident could be depending on the site location, etc. What was contemplated that there would be about 3 policies that would be issued. One was the main policy which would apply to the operator, then for the main suppliers, and the tier 3 policy was for the sub-suppliers. And pursuant to INBP in 2016, these were the 2 policies that were launched, famously called as NOLIP and NSIP, one dealing with the operator's liability and the other talking about the liability of, which was to cover the liability of the insurance. And we'll touch about, I think, before we get on to the other issues, I would like to mention the most important critical, that the constitutionality of the CLND Act, because it tries to limit, which is what is kind of required, a total liability of the operator and thereby the suppliers, has been challenged before the Supreme Court. So first it was challenged before the Kerala High Court, which upheld the constitutionality of the Act. However, it was appealed and there was another petition filed which is pending before the Supreme Court. Both the CLND Act and the CLND rules that have been framed under it have been challenged as they are ultra-violence and goes beyond the intent of the Act. These cases have been sub judice for a while now. Now, quickly moving on to what the current issues are. I think one and the foremost is what we've talked about a lot, is no private participation being allowed, and that is something that is required to ensure that the sector can kind of grow. Currently, private participation, and I think we were discussing this in the earlier session as well, is allowed as private entities being suppliers or contractors or even EPC contractors for these power plants. That is what is currently happening on ground and what is envisaged, not being in the capacity of an owner or an operator. Moving on, now I'll come to the CLND Act, where the suppliers and both Indian and foreign suppliers have been really concerned with this liability regime. So the concerns, if I were to divide them, they're broadly 2. One is the concern with respect to the right of recourse, which is provided under Section 17, read with Rule 24 of the CLND rules. And the other is the third-party claims issue, which is set out under Section 46 of the CLND Act. Now, starting with the right of recourse. So, what does the CLND Act say? CLND Act says once an operator has paid the compensation, which is prescribed and which is kind of designated, and again ARB is the entity which is authorized and empowered to notify a nuclear damage has occurred and then kind of go through the process of calculating what the damage is. So only once NPCIL or an operator has paid out the compensation, under the Act it has a right of recourse against the supplier in certain specified instances, and those instances are specified under Section 17 A, B and C. Now A says if it is provided in your contract, B says that if the nuclear incident occurs as a result or consequence of the act of supplier or providing a defective equipment or deficient services, that's when it kicks in. And third is an intentional issue where they've kind of damaged something intentionally or because of act of commission or commission that has happened intently. Now, the whole uproar and the concern that the industry has been faced, and especially the foreign suppliers, has been with respect to 17B, which goes on to give, and the argument, and the whole argument is that's additional ground which is not provided under CSC. Now, CSC contemplates A and B, so the right to recourse exists if it is provided in your contract, and or if it is an intentional issue. So the whole, so to speak, concern that the suppliers have had is that 17B is giving an additional ground for recourse, and which makes the suppliers uncomfortable. But however, the clarification, and here comes the clarification that the government has issued. Now, this has come out in the form of FAQs, first by the Ministry of External Affairs and in 2015, and thereafter in 2020 by the Department of Atomic Energy. And these clarifications, I think the main idea of these FAQs was to address the concerns that the suppliers have had. And the rationale that the Indian government and the various departments have given with respect to 17B is that in fact it's not an additional ground. It is, so to speak, a natural corollary of what you would provide in a contract. So in a supply contract, you would typically see that a supplier stands behind or warrants the products that it is delivering, or design, engineering, etc. And if there is a defect that it happens, then the contract will typically say that, oh, the contractor remains liable for this period and for this much quantum. That is something that is typically provided. So I think the rationale that the Indian government is giving is it's not an additional ground, and it's an argument that perhaps sustains this ground that it is something that would be provided in the contract anyway. So it's not an additional ground, and I think this is also supported by the Rule 24 under the CLND rules, which very specifically goes on to provide that a contract which should mention the right of recourse should clearly specify that what is the quantum that would be payable under this right of recourse, which is broadly the either 1500 crores or the value of the contract, whichever is less. So the contract should kind of cap the quantum of the liability that it can arise, and also the duration of this liability, this defect liability period, how long this liability would continue. And that is also something that is typically we see in various supply contracts, that a supplier will say that my defect liability period stays for this much period. Now, what Rule 24(2) goes on to say that this liability period should either be the product liability period which is provided in the contract, or a period of 5 years for which the initial license is provided under the Atomic Energy Act. So these products, as long as they're kind of mentioned, and product liability period is also defined as a defect in your either a patent or related defect in the equipment supplied or the services rendered. So broadly being, I think because of these reasons, the clarifications that have been given by the government, the arguments being made, that in fact the little b is not an additional ground. It is something that would have been provided. Agreed that it is not, but the uncomfort that the suppliers get, that it is something additional which is not there in the annex of the CSC, and thus an additional ground. But if you see it objectively and you kind of mitigate it, and that's one of the mitigations we'll talk about towards the end, that you could deal with it with contract structuring and getting adequate safeguards, and something that will not expand the liability of a supplier. So these, and also I think to be remembered that India has ratified and confirmed the CSC, and it is confirmed that our local laws are in compliance with the CSC. Now with that right of recourse issue, let's move to the other big concern that the suppliers have had, which is hailing from Section 46 of the CLND Act, which basically talks about the third-party claims. And if you would see it as a standalone clause, this is a, so to speak, a very innocuous clause which you will find in almost all statutes, which goes on to say that this act is not derogatory to the other laws that kind of prevail. So all the idea of this act was that the liabilities of an operator which could apply in case of a nuclear incident or a nuclear damage happening under other laws, such as the Environment Protection Act or under tort laws, would continue and would not get curtailed. Now, the interesting part was, and the concern that various suppliers had, and rightfully so, was that because of this, even the suppliers tomorrow could get third-party claims to say that there is a nuclear incident and thereby they need to pay for such claims. Now, again, I think Section 46 was various reasons where, and these are arguments which could be made tomorrow if a claim were to come, which kind of support that Section 46 is not really geared to address the liability towards a supplier. Now, some of the main arguments behind this is that in fact the overall scheme of the Act is to channel the liability towards the operator. The whole idea is to be the first port of the operator who's operating the plant is actually liable, and also to ensure that they're in compliance with CSC, which goes on to say that the liability would be with the operator and not with other person. So operator gets a right of recourse against the supplier only once it has paid the compensation. Now the other important reason here, and which was clarified by FAQs as well with respect to Section 46, was that the whole, this section was heavily debated when the bill was being considered by the Parliament, and there was a lot of push to specifically add the word supplier to this clause. However, after much debate, it was decided to drop the word supplier, and this section should apply only to the operator. Now, because of this background, while I think to reiterate, FAQs are not legally binding, and so are parliamentary debates. But all these are guidance factors, which tomorrow, if needed, can be relied upon as guidance. That was the intent of the legislature, not to catch the suppliers under the fold of Section 46. But having said that, if the liability, if the supplier has actually provided efficient goods and services, then of course the liability would remain. This is in an ideal scenario when there is no fault of the supplier with respect to either the works that they are doing or the equipment that they are supplying, and the arguments can be made that this section is geared towards purely the operator and not the supplier. Now, with these two main concerns and how they can be looked at slightly differently, I'll move to the other concern, probably the last concern, which is with respect to the insurance package. Now, the whole idea of the insurance package was to address the concern with respect to the supplier's liability and say that, oh, the supplier's liability is going to be covered with this insurance package, so suppliers need not be too worried. Now, in pursuant to that, INEP was kind of introduced. However, the way INEP has been introduced, and we have two policies, one for the main operator, NPCIL, and the other for suppliers, the total corpus that was to be introduced for this insurance package was 1,500 crores. However, unfortunately, the current level at which the insurance policy is about half of that value, based on the public information. There hasn't been that much money that has come to the pool for providing this insurance. And the other issue, there is one common floater operators policy, and this would extend to all the nuclear power plants of NPCIL currently. So NPCIL currently has about 24 operating plants. All of them would be covered by this floater policy. And let's say if an incident were to happen at one and that cap goes, till the insurance doesn't get reinstated and there isn't enough clarity on, because something fortunately that hasn't happened so far, is that what would be the reinstatement premium that gets paid, that would need to be considered, but only if the reinstatement premium has been paid and the insurance policy thereby valid, that it would continue to apply to the other. So these are some of the concerns that have stayed with respect to the owner's insurance policy. Now, stemming from this and totally intrinsically linked to the insurance policy is the supplier's policy. Because I'll take a minute to just kind of explain how this insurance package kind of works. So there is one policy that the operator has, and then there is a separate policy for the supplier. Now the prerequisite for the supplier's policy is that there should be a valid operator's policy in existence. Now that has to coexist, and that's when the supplier gets the policy, and even when a claim needs to be made, the operator's policy needs to be valid. Because in effect, the insurance provider would pay once, right? Because its total cap is 1,500 crores. What it will indemnify the supplier and pay directly to the operator, but it is actually just one pool of 1,500 crores because the right of recourse of the operator flows from there as well, right? So, but the concern the suppliers have had with this insurance policy is that A, they cannot get the policy until the operator has this policy and hasn't really claimed under that, because there is one policy covering all power plants and there could be different suppliers for each of the plants. And the limit is 1,500 crores, and if it gets, so to speak, utilized in one go, not much would remain for the others. I think I've covered most of these points. Yeah, and the coverage that the NSIP, the supplier's policy, gives is only with respect to 17(1)(a), which is provided in the contract, and B, so for defective goods. Obviously for intentional damage or any other claim, like under section 46, the insurance policy is not covered. The insurance policy is very specific to cover the liability under 17(a) and B with the total cap, and I think what we figure out, and this information is based on what we've found in the publicly available information, because this is based on the insurance policies which have been kind of issued. And again, the supplier's policy is also a common policy. So if there are a couple of suppliers, they will have to kind of work together to dip into this insurance policy, because there is actually one overall pool. So this unfortunately has been the concern with respect to the insurance policies, which were actually in fact supposed to be the mitigant and provide the suppliers with the comfort, as well as the operator with the comfort with the liability that could arise. Now, having discussed these issues, very briefly I'll touch upon some of the mitigation measures, which is the last part of the presentation. So now, first bit of, I think, what we've spoken about is the private participation, and we've touched upon. The way the current Atomic Energy Act is, for a private participant, be it Indian entity and foreign entity, and for both of them, the Atomic Energy Act will need to get amended to allow for a private player to either own or operate a power plant, nuclear power plant in the country. And for a foreign entity, this is further nuanced, because the FDI policy will need to have an enabling. And I totally understand there are, as Sharan was also mentioning, safety issues, etc., which will need to be kept in mind before private participants are allowed. So this will need to be a thought through and nuanced process. But unfortunately, if the sector needs to grow, this is something that will have to get done, and it will have to get done sooner than later. And that's why we see a lot of public news, at least, that has been going around for the last year or year and a half, starting with May 2023, when NITI Aayog first recommended that there should be private participation that should be allowed. And I think first at a general level, and then they've also touched upon in SMRs and BSRs that it should be allowed. And after that also there have been a couple of news items that you see which say that private entities should be allowed to do the construction and get into the expansion of the regulatory of the nuclear industry, in the Indian nuclear industry. But unfortunately, there's nothing that we've seen which talks about the amendments that are to be made and will see the light. Even a draft is not in. So this is something that certainly would be needed, and I think probably some things to address the safety concerns, etc. ARB being the regulatory authority, and because it has such strong and stringent safety standards, and absolutely covers the international safety standards, so they could perhaps come up with a different licensing regime. And probably the private participation could get opened in a staggered manner, perhaps for SMRs and PSRs first, and then for the larger nuclear reactors. Perhaps that's something that could be considered. ARB could say there are 4 processes that need to be followed today for providing the consent and the ARB clearance. Those further steps could be added, something to kind of ensure better safeguards, but for private participation to allow that enabling regulatory regime will be required if we want the private parties to invest both financially and even in research and development, which seems to be the agenda and the aim, and will certainly help the industry as well. So for that, what we still need to see for even BSRs, what is contemplated is, because the technology is kind of ready and the government owns and using the existing technology, even if the idea is to license this to the private players for them to then utilize and construct, the Act will need an amendment, and it will need to have an enabling provision to say that this licensing is allowed, and thereby pursuant to this licensing, the ownership could vest with the private entity. And obviously this need to be thought through and kind of keeping all checks and balances in mind, but something that certainly can be done with the government's involvement. And so one piece is this changes in the regulatory regime, and then the other bit I mentioned about increasing private participation is, and I think this was one of the comments also made yesterday by somebody from Hale, if I'm not wrong, that said that the government has done a lot for the semiconductor industry to push. Why the same cannot be done for SMRs or nuclear? So something, and there has been news items there which says that the government may come up with a PLI scheme to provide the incentives. Now this is twofold. One, it will attract the private participation, and it may also help bring down the tariff, which is another issue that the nuclear industry seems to tackle and needs to face to kind of grow the industry. Now, with the last slide, I think this is to address the various concerns that the suppliers have had, both foreign and domestic, with respect to the liability regime. Now, as I explained about the 2 right of recourse and the third party claims under Section 46, the arguments that could be made to support and control, or so to speak, cap the liability of the supplier, that along with mitigation measures that could be taken should be considered, which could perhaps address till the Act, that the CLND Act gets modified, which to my mind, I think CLND Act amendment happening in the near future I don't see, because I think if it were to happen, it would have happened by now. Because and there are arguments which could kind of support. Ideal scenario, of course, the CLND Act gets modified to remove the way everybody is happier, but in the meanwhile, with those arguments and certain mitigation measures, and now the mitigation measures, the first being of your contract structuring. You can make sure that your contracts as a supplier and the operator are well drafted. They provide for each provision very clearly as to what the scope is, what the liability is, as long as it can clearly demarcates these things, caps the liability, detailed limitation of liability clauses. Also a contract fault determination mechanism, which basically will set out in what instances would the supplier be liable, in what instances sit in the fold of the operator and owner. So as long as your contract is clear and well drafted, this could go a long way and help in case of all future claims or disputes that happen. Now, to address the Section 46 issue that we were talking about in the third-party claims, in this also we could have a detailed clause in the contracts which go on to say that in case of such other claims, the operator would be the main guy who would front it. And in a lot of these cases, obviously because if the supplier is a strong supplier and on ground, they could be made a party to such claims. And in that case, you have adequate indemnity provisions. And these are all contractual protections, but these are protections nonetheless, which could help in a case tomorrow. And lastly is, and lastly, but I would say very importantly, is the whole insurance package issue. So if things can be done to increase the pool, so that gives more comfort to almost all the stakeholders, operators and suppliers involved, that would really help. And I believe would go a long way to boost the nuclear power and its growth story in the country. With that, I think I'll close the session. Thank you.
Thank you very much.
Construction for modernization, we are talking of hastening the pace of the construction, engineering, and finding the solutions to, pace up the things, to fasten the things. So, as a service provider for the nuclear industry, for construction industry, we are like HEFT Cranes is a new startup in India, and I just wanted to emphasize on a few things before we break for the lunch regarding the constructability and modernization and how we can assist the main contractors to fasten up the things. The technology is advancing as we are seeing the evolution of the nuclear technology from the smaller 160 megawatt to 1600 megawatt units. So the technology is evolving. So same thing is happening with the crane industry also. So and we are pleased to just refer a few things here how we can help you with that. So HEFT Cranes is basically an Indian startup. It's a domestic company which is formed by some three very old crane industry companies in India. And the focus is basically to bring in this kind of services for the heavy lifting industry, where till date we used to look upon the services from the international players. So those kind of services we have to provide to you from a domestic company which can provide you the local, which understands the local issues, who understands the needs of the local industry, and try and provide you the same level of engineering and same level of construction methodology that you expect from many international players. So that's the basic focus. So we have a small vision of to provide you the best solutions which are available throughout the globe as being a domestic player. So we are just, as we are growing, so we are just going, like to tell you that our focus is basically on the bigger capacity cranes. Like I could see, I was really pleased to see the presentation from Dr. Sharan and Stéphane, and where they showed a lot of pictures with cranes, and they talked about the time period being reduced from say 5 months to 1 month or 1 year to 4 months by modernizing the things. So that was like there is a capacity enhancement. Like means what we are used to see the crane capacities of up to 1200 ton being used by NPCIL, their captive cranes, which are being used for the Kakrapar and Kodangun projects. And now the things are opening up. So we have domestically, we have now available the crane capacity up to 2000 and 2200 ton cranes. And we are going to increase our capacity up to 4000 ton by next year. We have plans, we are developing with the help of OEMs, we are developing some special models to cater to such kind of industries where if you could recollect, there was one slide in which Stéphane showed a picture of the 𝐓𝐈𝐌𝐄𝐒, the dome being erected. That dome was being erected by a 5,000 ton crane, ringer crane. So that is like what is available globally. So we are focusing to get that kind of capacity available in India by an Indian company. So we are planning to have that 3,200 and 4,000 ton crawler cranes available by next year. So means it will give you more flexibility. Means that kind of there is a ringer crane which is a static crane, but in 𝐓𝐈𝐌𝐄𝐒 they had a special solution for which they put the rail tracks for that crane to move from one unit to another unit multiple times so that both the units are simultaneously built up. So we have that flexibility that we will have the capacity of 4,000 ton crane. I'll just come to the coming slides. Presently, we have cranes up to 2,000 ton available in India, and we are very actively working in oil and gas sector. There are so many refinery projects and petrochemical projects which are going on right now throughout India. And our 2,000 ton crane, I'll just show you some pictures in the coming slides. So this is a 3,200 ton crane which we will have by early next year. So it's a twin crane. This is like assembled with the help of 2 into 2,000 ton cranes. They are put together with a special kit, and we have the huge capacities available to cater to your requirements. And with the help of these big cranes, like Dr. Sharan said that we are doing the motorization, the ring liners and the dome. If you are doing the reactor building in say 4 rings, you can do it in 2 rings now. So we have that additional capacity available. So it will again cut down your construction period very drastically. So these are the developments that are happening throughout the world in every sector. So the crane sector is also not left behind. So we just wanted to highlight these special features, and I really thank the NBP to give us this platform to showcase these capabilities. If you can see that we can lift up to 1,000 ton at 40-meter radius, more than 1,200 tons with a 117-meter boom length. So these are then this is a 4,000 ton crane capacity, which we have already placed the order, and it is under development. So as we are having this multiple options of that crane being on a ringer as well as crawler options. So whatever the application, we can customize it. We can use it as a ringer crane also, which is a static crane. Otherwise, it is a crawler crane which can travel also. So that kind of crane with 4,000 capacity, it will really help you to re-engineer your construction methodology and suit to make the construction much faster than what we are doing today. If you see this is the basic load chart of a 4,000 ton capacity crane, and here you have capacities of up to 1,500 ton at 40-50 meter radius. So these are huge capacities. So this will really assist you in coming up with faster construction ways. So I'm running through, since I know that you will be eager to go for lunch. So we are just showcasing some of the some major critical lifts which we had done in the recent year. Our organization is just 1.5 years old, so we call it a heavy lift startup of India. So, but still, during the last 15-16 months, which we are in operation, we have done a lot of challenging jobs in Barmer refinery and one petrochemical. This is the main fraction column which we lifted in Barmer refinery in April this year for L&T, and this was 740 ton weight. And you can see that this crane has a special boom, double boom. It's called the boom booster. So, and these were really very critical lifts which helped to put that piece in single piece. Otherwise, normally these kind of capacities are not available, people used to do it in double sections. So you have to do an in-situ welding, which took 1 month, and a lot of safety aspects were there, because you have to do a lot of scaffolding and the welding at height. It's always risky. So to avoid that, you have that capacities available, so you can plan accordingly. So we will be available for you to do any early studies, feasibility studies. We can always participate with you during the engineering stage, where we can give you the solutions for improving your time period and constructivity plans. We are doing a lot of heavy lifts in Panipat P25 project, which is an expansion project of Panipat refinery. And we also did Paradip PXPTN, is a petrochemical project in IOCL Paradip. So we did a lot of lifts there for Technip and Technimont also. So we are working with almost all the major EPC companies in India. And again, as Dr. Sharan said, that we are welcoming more EPC companies into the nuclear fold. So we look forward to be an early contractor, you can say, early involvement, where we can help with some more unique solutions. And as regard to motorization, we will provide a complete solution. When you are doing some modules, even structural modules also, you have to do a lot of detailing to see how you are going to lift it, because the CG may not be centric in these kind of modules. So we have designed a special lifting frames and special lifting tackles arrangement for these kind of modules, which can be lifted to save a lot of time on your technical structures around the main vessels or something like that. So this is really means this is the need of the day, motorization, and here a crane company can always help you in deciding what kind of modules you can go for, what capacities are available for you to decide the module sizes, and accordingly we have to do some more engineering for lifting it to find the ways how to design the lift apparatus for that. So we are providing those kind of complete solutions for that. Here we just did this main pressure column in Panipat also. So he will be going to the next project in New Aligarh as well as Panipat package. So these are the lifting accessories which you need for these kind of heavy lifts. So like we have this spreader arrangement which can lift up to 1250 ton with a 14-meter span. So whatever the size of the equipment, right now till now just recently we had it, we lifted a 14.5-meter dia regenerator in Panipat. So we are providing those kind of tackles or accessories what you need for lifting solutions. Similarly for structures. So this is just like a small introduction to our company, and we welcome your any request for any participation in forecasting or maybe the field studies. So we are here for we have a booth also here. Anybody is welcome, and we can discuss any of your requirements for that. So this is just our contact details also. Thank you very much.